Hello friends, in this video we are going to discuss something about linked list. What is a linked list? Basically a linked list is a linear data structure which can store data in non-contiguous memory locations. So we know that array is also a data structure which is a basic data structure which can hold data values in contiguous memory locations, but in this linked list, if we want to store data in non-contiguous memory locations, that is data scattered in a scattered way and yet linked to each other, we can implement that by means of this linked list data structure, and this linked list data structure helps us a lot in the study of the data structures. So we will just discuss a little bit of theory, a little bit of pictorial representations about the linked lists, how many types of, what are the different types of linked lists are there, and a brief overview of the linked list will be discussed in this video, and afterwards I am going to perform the primitive operations which are done on singly linked list, doubly linked list, etc. And now I am just going to see whether what is a linked list. Basically, what is the structure of a linked list, and in order to go on with the study of the linked list, we need to see first the simplest of all the linked lists, that is the singly linked list. So the singly linked list is nothing but, I will just show it on the board. The singly linked list looks like this, looks quite like this. Suppose this is a memory block, this is another memory block, this is another memory block, and this has two portions. This memory block has two portions, this memory block has two portions. These are similar memory blocks having two portions. One will contain the data value and another will contain the address. This also contains data, address, and so on. So this is the way data are dispersed and stored in a scattered way in the computer system, in the computer memory rather. So we can place data in non-contiguous memory locations, but how to maintain the link between the data? We maintain the link by means of pointers to this linked list node, pointers to this node data type. So this is called a node. That is the memory block. This is another node. This one is another node. And so these are basically nodes, and we will have pointers pointing to this node. The address of the next node will be stored over here. The address of this node will be stored over here. And in this way, we can build a sort of a linear data structure which are linked to each other in this fashion. So if we put the data in a scattered way, if we store the data in a scattered way, still this address, since we are holding this address in this address field of the next node in the linked list, we are able to associate this node with this node and so on and so forth. So what will happen to this this node's address? That will be stored by a list pointer, which we can take it as P, and this will hold the address of this node. So suppose I write an example to show you clearly. Suppose this is a node, this has two parts, this is a node, this has two parts, this is a node, this has two parts. For the sake of simplicity, I am taking three nodes. I could have taken much more nodes in our example, but for the sake of simplicity, I have taken three nodes. That will suffice the explanation. And now I will assign some address 65536, 65586. Suppose this is 75536. Like this, these are non-contiguous memory locations. Suppose 5 is stored here, 10 is stored here, minus 10 is stored here, and this will be linked to each other by these pointers. And there will be a list pointer which I will always use as P, which is the list pointer which will hold the base address, which will hold the address of the first node in this entire sequence used here in this singly linked list. So P is equal to, I will write 65536. So this P is equal to 65536 means P is a pointer to this data type, that is the user defined data type, which we will just explain it in a bit. So, and this P is a pointer which holds this value, this address value, and there will be another pointer here, that is the address of the next node, which I have explained before, and this field will contain 65586 because this is the address of the next node, and this will hold the address of this node, that is 75586, and this node is not pointing to anyone because this is the last node in the entire linked list. So in the case of the last node, we will just keep a null pointer over here. A null pointer means a pointer which points to no node or nothing. So this is a null pointer which helps us to see if any node has a null pointer in the next in the address field, we can easily conclude that that is the last node of the entire sequence. And in this linked list, so we have drawn a linked list having 3 data values placed in non-contiguous memory locations, and each of those data values are stored in some memory blocks having some definite memory addresses, and the blocks are interrelated by means of pointers to the particular data type which we will declare in this node declaration, node data structure. And this P is a list pointer, and it holds the address of the first node of the entire sequence. So P is the list pointer. So P is the list pointer. So this is a simple example of a singly linked list. This is a singly linked list, which is the simplest of the different types of linked list which we will study later on. And this is the easiest example, it is the easiest representation of a linked list data structure. So this is a linear data structure where data are stored in non-contiguous memory locations and are linked to each other by means of pointers. So this is a brief overview of the linked list, and in order to define this node, we need to define a structure. That is, I will just declare the structure in order to show you how we are going to handle the creation of this entire memory block, this entire memory block, this entire memory block, etc. So for that, I will write a structure declaration. Let's write the structure declaration over here. Let me write first, and I will just show it to you because I think it is obscuring. The view is being obscured by me. Typedef struct. Suppose typedef struct node. I am writing typedef struct node, and I will take 2 things, that is, I can take an integer data, I can take a character data, I can take any data of any data type. So let's take some integer data because we have used some integer data in our example. So we will take the data field to be of the integer data type. So I will write int data or int item or int element, anything you can write, int x, int y, int z. So I am writing int data. The next thing which we are going to write is struct node star next. Struct node star next. So this is what we have said, what we have written, int data, that is the integer value, this portion. And for this portion, we will have to declare a pointer to the node data structure, that is struct node star next, and write it as, suppose I am writing it as node. Now, suppose I will take a pointer after the declaration of this structure. I will take a pointer like this, node star P. So what is node star P? The P is a pointer. P is a pointer which points to a data of the data type node. And the data type node has been explained by this structure declaration, structure definition. So node star P is a node pointer, and we'll write like this. In order to create a memory block, in order to dynamically create a memory block, we will write one line of code that I will show you. That is, P is equal to node star malloc size of node. So what we have written, P is equal to node star malloc size of node. So this helps us to create one memory block like this in the memory, in the computer memory. And suppose whatever memory is being reserved for this purpose, whatever memory is being reserved for this purpose will be stored in, will be assigned, that address value will be assigned in this pointer variable P. And suppose we are going to reserve this memory region. So 65536 will be the address. It will have two parts, that is the data part. This is the data part, and this is the next part. This is the next part. And this P is going to hold this address 65536. So in this way, memory blocks or nodes are created in the entire discourse of singly linked list or any other linked list. So in this case, we are using the singly linked list. So in order to create a node in the singly linked list, we have to maintain this sort of concept in order to handle the creation of any particular node in a singly linked list. So we are going to discuss various other types of linked lists which are there apart from the singly linked lists. So let's get on with the study of the other linked lists as well. So there are examples of other linked lists as well. So let's get on with the other linked lists. So let me just rub off the board and come back to you once again. So coming back to the other types of linked lists, there can be doubly linked lists, there can be circular linked lists, there can be circular doubly linked lists. So let's write some pictorial examples or representations in order to show you how they are used in the discourse of the data structures. So suppose doubly linked list looks like this. Suppose there is a node, there is a node, there is a node like this. It will have two parts. This will have, rather it will have three parts. It will have three parts. It will have three parts. So this one is an address field. This one is an address field. This one is the data field. This one address, data. This one address field, data field. So here there are two address fields and one data field. Two address field, one data field, and so on. So that's why, because it is holding two addresses, so in that case we can for that we can say, we can name it as doubly linked list. So this is an example of doubly linked list, but why how it is linked to each other? Suppose doubly linked list will be linked to each other in this way. This address portion, this address will hold the address of the right side node, and this address portion will hold the address of the left side neighbor. This address portion likewise will hold the address of the right side neighbor, and this address portion and this address portion will hold the address of the left side neighbor. And what will this point to? This has no neighbors on the left hand side, so this left pointer will be taken to be null. This will have also this node will also have a right pointer set to null as well, because it has no right neighbors on its right side. So this is the example of a doubly linked list. So it is called a doubly linked list. So let us just write an example. Suppose this is a node, this is a node, this is a node. These are the portions. Suppose it contains a value 2, it contains a value -4, it contains a value of 0. It is 65586, it is 75536, it is 95586, something like that. Now, this portion, this will be linked in this manner, this will be linked in this manner, this will be null, this will be null. So, what will this address field contain? This will contain 75536. So, let's write 75536 over here. What will this portion contain? This address portion contain? This will contain the address value of the left neighbor, that is 65586. What will this contain? Likewise 95586. So, and this will contain the null value. And what will this contain? This will contain 75536. 75536. So, in this way, we can represent the doubly linked list. What will be the structured declaration? Structured declaration is nothing but very similar to the one we have shown before, and that will be like this: type def struct. Suppose I am telling this to be dnode, to denote that it is a doubly linked list node. Int data struct dnode star, sorry, not next. There will be a left pointer and a right pointer. So I will take struct dnode star left star right. So we have two pointers, left pointer, right pointer, denoted by struct denote star left, struct denote star right. Now come to here, we come here and write like this, denote. So this is the structure declaration of this type of linked list. So this is the doubly linked list. Now we can have another type of linked list which is called a circular singly linked list. So let's write the circular singly linked list. So there are other linked lists which can be called as suppose circular linked lists. So let me write like this: circular singly linked list. Circular singly linked list. What is circular singly linked list? Let me just give a pictorial representation in order to make you understand. Suppose there are three nodes. Since it is a singly linked list, it will contain two fields, a data field and an address field. Suppose it is 65586. Suppose it is 65536. Suppose it is 65516 or something like that. It has a value 5, it has a value 10, it has a value of 15. So it will contain 65536. Just as in the case of singly linked list, we are just writing it as a simple singly linked list. So it will contain 65516. This will contain a null pointer in the normal singly linked list. This will be this address will be held by the list pointer p in the singly linked list. But in this case, since it is a circular singly linked list, what will be done over here? This will not be a null pointer. This pointer, that is the rightmost node, the address field of the rightmost node in the linked list will not contain a null pointer as was seen in the case of the singly linked list. It will contain, this will contain the address of the first node. Address of the first node. So the first node can have a list pointer. First node can have a list pointer, suppose p, and it will contain 65586, and this 65586 will also be stored over here, and that means there is a link, there is a pointer which points to and this pointer points to the first node of the circular singly linked list. So this is the circular singly linked list. So this is the circular singly linked list, and there is another linked list which is called circular doubly linked list. You can easily understand that it will be quite similar to the doubly linked list, and it will be just the data will be stored in a circular manner. So suppose this is a doubly linked list, like this. This is 65516, this is 75516, this is 85536, this is 5, this is -5, this is 10 or something like that, and this will contain what value? 75516. This will contain 65516. This will contain 85536. This will contain 75516. And in the normal doubly linked list, which we have discussed before, we have seen that this pointer and this pointer will be will be null pointers rather. So in this case, there will be no null pointers. There will be perfect utilization of these null pointers in the way that this will hold the memory address of the first node in the entire sequence, and this field will contain the memory address of the last node of the entire sequence. So this will be linked to this node, and this will be linked to this node. So this will contain the value of 85536, that is the address of the last node in the sequence, and this will contain the value of the address value of 65516, that is the address of the first node of the entire sequence. So this brings us to the classification and overview of the different sorts of linked list, and if you have any doubts relating to this entire discourse in this video, you can well post your doubts and queries into the comment section below so that I can address them. Thanks for watching this video.